Greetings and welcome to the 5th edition of Meat Cutting Lecture. The art of sausage making. There are three primary ingredients in sausages: fat, meat, and flavorings. As we know from yesterday, fat is not flavor. It's the carrier of flavor. It aids in the development of a desired emulsification in sausage making. Now you're thinking, emulsification, that's like making a hollandaise. It's taking two things that wouldn't go together, putting them together using a whisk. Well, that's kind of what we're doing. When we separate the meat and fat mechanically, it doesn't go back together by setting it on the table. We use a grinder. We create this method of putting them together evenly and equally through grinding them. Meat is one of the primary ingredients in sausage as well. It's limited by your imagination. If it's meaty, you can make sausage out of it. The only thing you have to take into consideration is if it's lean meat, you need to add some sort of fat or moisture to it. Sometimes you'll see different vegetables like carrots or parsley or spinach added to sausages to maintain the moisture content. Flavorings are going to be traditional to regional, and basically are also limited by your imagination. You can make the old faithfuls like bratwurst and kielbasa and linguiça and andouille, but you can also do anything you want. You're not limited to making just a particular kind of sausage. So think outside the box. Go crazy. Make sausage. There are three classifications of sausage. The first one is fresh, or in French we call it saucisse. It's any kind of sausage that's not smoked or cooked. Obviously, it's fresh. It's made from meat. Figure it out, right? All of this stuff is meat. If it's meaty, you can make sausage out of it. Second classification of sausage is dry, or saucisson. It's a sausage that has gone through a process of curing, or dry curing. What that means is that we've dried the inside at the same rate of drying the outside. And we are focused on creating an atmosphere that has very low humidity, has a constant airflow. The sausage can dry as a minimum of 3 weeks and up to 6 months, depending on what kind of sausage it is. There are natural additives that are added in the dry curing process that help to do a couple different things. Things like you can add sodium nitrate or nitrite to your sausage, which helps to remove the moisture more expeditiously. Or you can also add dextrose or different kinds of sugar, fermento, corn syrup solids, which aid in the fermentation and develop an incredibly flavorful tang to the sausage. The third type of sausage is called boudin. A boudin is broken down into three subcategories. The first type is called a boudin blanc, and basically, as the name might suggest, it is a white sausage. It's made with white meat. Check it out. It can also be made with fish, and it's bound with cream and eggs. Everyone thinks that because it's white, it's lean, but it's crazy because we are adding generally a tremendous amount of cream and eggs to make it nice and creamy and delicious. It's also a very smooth consistency. Generally, it's ground 3 times and then passed through a tammy. Very similar to a mousseline. Boudin Noir is our second type of sausage, second type of boudin, and it's a blood sausage. Noir means black. It's made with blood. It's also known as blood pudding. Sometimes it's bound with rice, kind of down where you see Central and South America. Rice is one of the primary ingredients used to bind it. It's difficult to attain a true, die-hard blood sausage in the United States, or to get blood to make it, because we pasteurize apple juice, for Christ's sake. So getting unpasteurized blood is going to be difficult to attain. The reason you have to get unpasteurized blood is because part of what you're doing is you're flavoring the blood and poaching it, thereby setting it or coagulating it. If you were in Louisiana, maybe you could go to Sam's Bar and True Blood, get some bottles of unpasteurized True Blood, but it's probably pasteurized because, you know, all that working out there. All right, so that's one way. And the third type of boudin, rather, is of southern variety or southern influence, generally pronounced boudin, and kind of a multiple syllable application there. It's a French Creole primary descent. Primary meat that you're using as the base, which is the more ground meat, is chicken. It also will have chunks of crawfish, pork, whatever other kind of things they put in it. You also see generally a lot of fresh herbs. Sometimes it's freakishly spicy, and sometimes it's you can't even pick up spice at all. A casing. What exactly is a casing? There are 3 different kinds of casing. The first one we're going to talk about is collagen. Imagine we take a skin of an animal and we hang it on a wall. We pin it up and we let it dry a little bit. Inevitably, you've always seen at some point or another people scraping down the weird tofu-looking stuff from the interior of that. That's actually called corium. And the corium is what we use to make collagen casings. We take the corium, we put it into a vat, we add an acidulated product which causes it to blow up and flare up like fluffernutter. We then put it through a system of grinders and purifications, and then lastly we shoot it out an extruder onto a metal tube where it's hollow and dries, and then we crush it up like an accordion, and it's this amazing thing. If you've ever had salami or summer sausage, that is a collagen casing, or an example of a collagen casing. Next we have synthetics. Synthetics were developed because people were primarily using natural casings, which were the intestines of animals, and whether they thought that was weird or not, the synthetic casings were developed because they were more consistent. We could also develop them to be color-coded so that you knew that the red was for one thing and the white was for another thing. The other thing was you could actually get them where they had, it's almost like a radial tire. A radial tire has wires in the rubber, and you could get casings that had additional things that were put inside, or wires or plastics that would help to make them stronger. They also sometimes will put food-grade glue or adhesive on the inside so that it sticks to the meat better. Natural casings are usually the large intestines of hog and sheep, or anything that held liquid or something to that capacity. So stomachs are used, the bung, which is the last 2 to 3 feet of the rectum, things like that are used to hold meat and to cook it and preserve it. The exciting worlds of brine and cures. Traditionally, the reason behind brining or curing was to preserve foods in the fall for the winter months. So it was inclusive of canning, it was inclusive of smoking, it was inclusive of salting, and different methods of curing to put food up so that they had food available for the winter. It extends shelf life, and we know that it adds value through changing the weight and the flavor, and it also, right now, it kind of has this mystical feel. You know, if we put a chutney or some sort of canned item on the table, people freak out and they think that we put all this time and effort into it, when basically we just cooked it over a low flame and added some vinegar and some mustard and called it a day. There's 2 primary ingredients in brines, that being salt. Salt is hydrophobic. It helps to push water away. What's happening is it's removing salt from the interior of the cell. Imagine that we were in the Magic School Bus, we jumped inside, we were running, we are going into the interior of a fresh ham that we've applied a salt cure to. In the Magic School Bus, we can actually see on a molecular level the cell, which looks like a tiny little balloon. It's filled with water. And as we sit there in the Magic School Bus and watch what's happening, the salt penetrates through the fresh ham or through the muscle tissue through a process known as osmosis, or the transference of one thing to another through liquid medium. So the salt gets to the cell, it pulverizes the exterior of the cell by creating little holes, thus removing the water or the moisture from the interior of that cell or that little water balloon. So now we had salt coming in through osmosis, now we have salt pulling the water out through osmosis, taking it to the surface of the meat, creating little spent skeletons that we'll talk about in a second. So remember, tiny little cellular skeletons sitting on the exterior of the meat. Good. We'll call it PPF. Keep that picture. Next, we go to the second ingredient, which is sugar. Sugar is hygroscopic, excuse me. It attracts water. It's also a fat, so it also attracts flavor, kind of like that hollow bubble when we were talking about fats not having flavor, but the absorbent of flavor. It fills in a small percentage of the moisture, which has been removed by salt. So you're thinking, why do we take the water out? Now we're putting it back in. So it's kind of like taking our water balloon, which we're looking at through, or the cell, looking at through the window of the Magic School Bus. We've taken the water out, and instead of putting in water, we're putting in jello, right? So we've changed the molecular weight of what we're putting in there. Sugar also counteracts the astringency of salt. A cure is the dry application of salt and sugar. A brine is the wet application and is sometimes called a pickle. What differentiates a pickle from a brine is the addition of vinegar. So you would have salt, sugar, vinegar in water. That would be called a pickle. Additional ingredients are flavorings. Depends on your own imagination. And then we also have sodium nitrate. Sodium nitrate had an early interesting beginning. How it got from explosives and solid rocket propellants was somehow a mystery. Some believe that it was used in a war, and as the soldiers were trying to get meat to transfer, some of this spilled on the meat. They realized that it dried, and they realized that it preserved it, and they could carry it for long distances and eat it. Although salty, it seemed to keep them healthy. It's also called saltpeter, and where it got its name saltpeter was from apparently the use in the military to reduce the sexual production of the soldiers in the army. It made the peaters sad and made them unproductive. So that's where that comes from. It's also known to have health benefits. It helps to oxygenate the blood. It's known to be in high concentration in dark leafy greens. In unusually high doses, it is not good for you, so you want to be careful like that. Sometimes you'll hear stories of people eating or consuming tremendous amounts of beef jerky on a hike. Bad for two reasons. Generally, you're not consuming a lot of water, so you eat the jerky, it sits in your stomach, and then when you actually do drink water, it swells up into basically the equivalent of an inflatable balloon that is now in your colon and making the passage of anything else quite impossible. The other thing is that it completely dries your mouth out, and because generally it has high concentrations of sodium nitrate, it actually elevates the speed of your heart, so don't want to do that. Sodium nitrite is also added. It's nitrous acid or sodium salt, and basically what it does, it helps to fix the color and also works as a preservative in meats and fish. When it's pure, it has a white, slightly yellowish crystalline powder. Sometimes you drive across the west in the desert and you'll see deposits of this on the ground. It looks like a crystal meth truck spilled there. It wasn't crystal meth, generally. It's soluble in water, and it's also hygroscopic. It slowly oxidizes and changes to sodium nitrate when exposed to water. The saturation point is the point at which a brine or cure will no longer successfully remove moisture from the meat. It's reached its load. It's not doing anymore. It's not going to remove any more moisture successfully. Once the product is done brining or curing, you generally want to rinse it off. It's much like shocking vegetables after we blanch them. We want to stop the cooking process. We want to stop the curing process. Then we want to dry them under fans before smoking. Primary reason is because when we put something into a smoker that we have cured, the moisture creates a barrier that the smoke will not penetrate through. So by putting it under fans, we dry the exterior. And remember I told you about that stuff to remember later is the PPF, or the spent little cellular skeletons on the exterior of the meat. Well, when that dries, those little skeletons, they form a substance or an exterior known as PPF, or proper pellicle formation. Proper pellicle formation is water-soluble proteins which are dissolved through the process of brining or curing that rise to the surface of the product through osmosis and settle on the surface. There they form a shiny varnish-like coating upon drying. It's a semi-impermeable surface, which means that it allows moisture out and it allows air in. So we want the moisture out and we want smoke in this instance. If you don't dry the product before smoking, it will not absorb the smoke. The water creates a barrier for smoking. Another means of expediting the brining process is using something called an arterial brine or an arterial cure. Basically what you're doing is you're utilizing the natural network of blood vessels. You're looking at specifically in the leg, the femoral artery, which is on the interior of the leg. If you were doing fresh ham, you would look on the inside of the leg just below the H-bone. You'd find a big tube, which is the femoral artery. You would take this thing that looks like a bicycle pump with a siphon tube that you put into your brine on one end and a long needle on the other. You would insert that into the femoral artery, fill your chamber with the brine, and then pump it in. And this is very cool because it actually pumps up like a balloon. And what you're doing is you're putting that brine into the interior of the meat without jeopardizing the integrity or ripping to shreds the muscle fiber. The brachial artery in the shoulder, or the Boston butt, you'd use to do the same thing. When you're thinking about when should I use a brine over a cure, the primary determining factors is going to be size, shape, and density of the product. It's also going to help you to understand how long you would leave something in the cure or brine as well. So for something that is not uniform, let's look at a salmon. So when you think about a side of salmon, if you were to imagine a side of salmon, so imagine I'm drawing a side of salmon here. So I've got a side of salmon. If I'm looking at, I did a cross section. Imagine here we have the little belly, and then it goes up to the fillet, and then this is the skin side. Well, here it's thin, and here it's thick in our imaginary picture. What the cure allows me to do is I can put a thick amount of cure or a heavy amount of cure on the thick part, and I can put a thin amount of cure on the belly. So let's imagine we see the whole side. So in the middle where it's thickest, I can put a lot of cure, and on the belly and the tail, I can put a very thin amount. And that's what we're going to do. That's